All right, so to start, I want everybody to say hi, Cam. Everybody, please say hi, Cam. All right, because Cam's going to have to watch our video later today. All right. Who? All right, so here's what I'm going to do, guys. We got to a point yesterday where we said that we were going to use the calculator to help us identify the proper Y values by using a zoom fit. And you guys thought that was pretty cool. So what I'm going to do is put these two equations into the calculator again, right? So we had the what? We had the 0.18x plus 20.64. 0.18x plus 20.64. So there's that one. And then we had the 0.26x. All right, and then what we said, guys, right, was we can only see a little something because we don't have the proper domain. And we said that we want to use 0 to 500, right? So what we said we would do was go to the menu and go to the window and go to the window settings. And that I only wanted you guys to adjust the what? The x values, the minimum and maximum x's, right? So we're going to go 0 to 500. And then I said, leave the y's alone because we're just going to hit OK. And that's all we saw, right? And then I said, the nice thing that we can do is the calculator has this option, zoom fit. And what that does is it puts the data right into our calculator and finds the appropriate y value without changing the what? The x values, right? So if I went back into the menu and I looked at my x values now, right, these stayed the same, didn't they? And the calculator automatically gave me the values down here that best fit the graph, okay? So utilize that function, okay? And then what was nice about that is it also told me what scale I can use here for the y's, right? And so on my graph, we went up to 150, right? That look all right? Now, what do you guys think I'm most interested about in this picture? What would you be most interested about? The points on the line, most specifically, which point? The point where they intersect, right? Now, there are a lot of ways to do it, okay? Some of you guys like this one. We go to menu, we go to analyze, we go to intersection, all right? And then it's this idea of lower and upper bound, and all that means is I got to put this vertical line to the left-hand side of where I want to find the intersection and hit enter. And then as I slide it to the right, it creates a zone where it will find the intersection, right? And so there it is, okay? That's wavy. Now, if you didn't want to do that way, the other way you could do it is by going to menu, geometry, where do points or lines intersect? And then you click on one of the lines, you click on the other line, and it literally pops up. So you can do it whatever way you want, okay? Other ways, yeah, there's other ways. Those are the two that I think you're probably most familiar with. Now, I got to get this on paper. You guys agree with that? How many points do I need to graph a line? Not a trick? 2, right? 2. So right now I know 1 point that's on what? On both of them, right? Do you guys agree that I also know these points over here? Don't I know the y-intercepts? Because if my equation is this, what's the y-intercept? 20.64, right? All right, so on my graph, I'm going to graph the cost one first. So on my graph, I'm going to go to 20.64 and put a point. 20, so just above that, right? Oh, wait, my whole thing moved. Hang on a second. My whole thing moved. There it goes. 20.64. And then we know the point of intersection, 258 and 67-ish. 258, all right, 258, where's that going to be? So it's these are by 20s. So 220, 240, 258 is going to be just before this. And what was it? 67. 258 and 50, 67. Right? Again, it's all about scales at this point, right? Because we're jumping by 10 over here, we're jumping by 20 over here. So it's a little confusing, but nonetheless, and then we connect it with a line. And I was actually just looking at your test, guys. I can tell you right now, you're going to have to do this exact thing on your exam, okay? All right, so this right here represents my cost. So we got that one. Now I need to graph my revenue function, right? Guys, your revenue function, if you don't sell any widgets, how much money do you bring in? Zero, right? So are you surprised when you look at this, that the y-intercept of that is what? Zero, right? All right, so the revenue function starts at 0 and intersects at the same spot as the one that we just graphed, right? Just like that. So there's cost, there is revenue. And they crossed at 258 and 67.1. Right, so we got a really great accurate graph now, right? Because we utilized the capabilities of the calculator, right? Part B, write an equation that can be used to determine the number of midgets, the number of widgets that must be produced for the revenue to equal cost. Guys, if I want revenue to equal cost, then don't I want this to equal this, right? So I want revenue to equal cost, so I want the 0.26. It wasn't 0.26, it was 0.2, 0.26W equal 0.18W plus 20.64. Guys, didn't we already answer this equation? Where does the revenue equal the cost? Bang, right here, correct? All right. Good? All right. Part D, same question. If profit, guys, how do you make a profit? How do you make a profit? You make a profit when the money that you receive is more than the money that you spend. Correct? Yeah, I mean, so that makes sense, right? So profit is defined as revenue, which is the money that you what? Bring in, minus cost, which is the money that you spend, right? There's your profit. So in this case, profit would equal 0.26, 26W minus that. Notice one thing that I did right there. It's super, super important. What did I do with the cost function? I put it in parentheses because I want to subtract all of the cost, not just the first thing in the cost, right? All right, and then it says use your graphing calculator to graph the profit function. So now I wanted to graph this from 0 to 1,000. Okay, so how many lines am I going to graph now? Is it still going to be 2? No, profit's just going to be this one line, right? So it's going to look something like 0.26W or X minus 0.18X plus 20.64. Now I'm going to hit enter and I'm going to see it, right? I'm going to see it. But what's the one thing I didn't consider? What did the question ask me to do? It said graph it on the interval 0 to 1,000, right? So now I got to go back into the window, change my maximum to be 1,000. And then ask the calculator to do another zoom fit. And there you have it, right? Guys, notice something about this. Kind of interesting when I put them all in the same curve, right? Where do you notice this intersects? Isn't it at the same spot? Because guys, when my revenue equaled my cost, as soon as I hit this point, everything after that became profit, right? Yeah. And so the profit function will cross at the same value as where this intersected, right? So that's not shocking. All right, so where did that one start? That one started down here at 258. All right, so now we got this window that goes out to 1,000. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 1,000. All right, the profit function, and this is going to be the number of widgets. Notice how did I label profit? I called it P of W, right? Because it's all in terms of the number of widgets that I sell, correct? So this is out at 264, which is going to be right around here. How many points do I need to graph this? 2, right? So right now, the only point that I really know is this 258, right? I know that this is crossing at 258, okay? I need any other point. I know, I just need any other point. Doesn't the calculator produce points for you? Right, so if I go to menu and I go to trace, I can actually ask the calculator to trace to a particular point. I'm gonna go to graph trace. All right, and here's the deal. I gotta figure out which graph, oh wow, how'd that happen? That's all right. I wanna figure out which, I don't know why I did that. It was odd. Graph trace, okay, so I gotta pick which line I wanna trace. So once I pick graph trace, if I use up and down, I can toggle between the lines that I want to find another point on. So I'm gonna pick the black line. I want to go out to, let's go out to 1,000. And at 1,000, I just typed it. Yeah, so once you're in graph trace, if you just type in a number, it'll go to that number. Now, it's the calculator will do weird things like this, guys. This is 1,000, all right? It just puts it in scientific notation. And that at 1,000, I'm at 59.4. All right, so our profit is 59. So we'll go 10, 20, 30, 40, 50, 60. So at 1,000, I'm at 59.4. Thank you, sir. Bang. And this, guys, cross out F. I don't really care about F. We sort of just did that. It says, guys, what's the minimum number of widgets I need to sell in order to reach a profit of 40? This is one of the most important questions on this, okay? Guys, I want to make 40 bucks making widgets. This is a lot of work to make 40 bucks, but I guess that's what we want to do. Do you guys agree that to make $40, I need to figure out where the profit function intersects what? Intersects 40, right? I want to make a $40 profit, so I want to know where these two things cross. Well, guys, hey, let's use our tool. We go back to here. So I want to know where the black line crosses 40, right? Do I know where 40 is? I mean, I got an idea where it is, but is it graphed? No, so let's hit tab and let's graph 40. That seem okay? And then we just talked about how to find an intersection. So I want to find the intersection of, okay, so this is the weird thing, guys, right? The weird thing is when you ask to do it that way, it wants to know which graphs, and the way that it asks so is by clicking on them, right? So I want to know where the purple and the black intersect, and then it asks me to give that upper and lower bound, right? That's the way it works with that. If you do it, guys, using the other method, watch, using the geometry method, then all you do is click on both graphs and it automatically pops up. Okay, I like the geometry method better. I'll show you another reason why in a second, okay? How many widgets do I need to make a $40 profit? 758. All right, let's move on. I've had it with widgets. Shayla, I want to show you one more thing about why I like that geometry method better. Watch this, guys. All right, so here I have a third, a fifth degree polynomial. You guys haven't learned about these yet. But I'm going to have it intersect something here. How many times does that orange line intersect the green line? 3 spots, right? Now here's the thing, guys. If you use the geometry method of intersection, what's nice about the geometry method is we click on the green graph and we click on the orange graph, and what it actually does, how many points are on here now? 3. So it will, and they, in this case, they're so close together, they overlap, but it actually finds all of them in one step, right? So later on, when you get to having to solve problems where we have third degrees and things like that, that's a way that you can get all your answers in one step, okay? Well, in this particular instance, your table would be jumping by one at a time unless you changed it. Are these going to be even on your table? No, right? Yeah, so this is easy. This is definitely the easiest way to get your answers. Good? Let's go. This is a really, this is one of those topics, guys, that I almost hate having to teach you because it's such an antiquated tool, okay? Systems of equations. Guys, your calculator has the ability to do everything that I'm going to show you without you having to do any work at all, okay? And you guys already know how to do this. In your calculator, I want everybody to go to add a calculator. And everybody knows where to find and solve, right? Well, in that same area, bless you, is solve a system of linear equations, correct? So, if we look at our first example here, right, what variables do we have? X and Y. So, I have two equations with an X and a Y. Is everybody able to find this? All right. So I hit OK. And what is it looking for me to do? Well, it's looking for me to enter those two equations. So I have 3x plus 2y equals -9. And 2x plus y equals -7. Oops. And we hit enter. And there's our solution, right? The value of x is -5. The value of y is 3. Well, I'm going to get there. Yeah, that's where we're going to go. And that was what my next sentence was going to be about. My next sentence was going to be about, well, why do I feel bad even having to teach you these next lessons? Well, it's because, quite honestly, it's a waste of your time, okay? You have the LinSolve to be able to do this. And anytime you have to solve a system of equations, you're going to do what I just showed you in the calculator. Even if it says, so what? Show your work. Because it's so much easier to do these problems when you know the answer ahead of time, okay? Not to mention the fact that if you can't do the work, you at least will get partial credit, right? So we're going to do that each and every time. But unfortunately, the requirement is that I show you the method to solve it algebraically, all right? And it's quite possible, if not probable, that they're going to tell you that you got to show your work, right? So we have a couple of methods that we can use to solve these. Here's the one that I prefer, okay? Here's the one that I prefer. If I added these equations together, I mean literally added them, how many x's would I have? 5. How many y's would I have? 3. And then I would have -16, okay? By adding the equations together, did I get a variable to eliminate? Or did I still have x's and y's? Still had x's and y's. Not a good thing. So I want to add the equations together, guys, so that when I do so, a variable goes away. Well, the only way for that to happen is for me to have a number like 5y and -5y, right? Or like 3x and -3x. Agreed? Right? So when I look at this, I have to decide, how am I going to get that to happen? Well, do you guys agree that I can take an equation and I can multiply it by any number And as long as I multiply the left and right sides, the value of the equation stays the same. Okay? If you don't believe me, if you think I'm lying, all you need to do is this, right? So if I was to do this as a relation, here's x plus y equals 3. And we get an equation, right? Well, if I was to now do 2x plus 3y equals, equals 6, right? I said that this was x plus y equals 3, right? 2x plus 2y equals 6. What did I do? I took that previous equation and multiplied everything by 2, right? And if I graph this, what happened? The red line went right on top of the blue line, right? So it's the exact same equation, right? So by multiplying by a value, it doesn't change what I had originally, okay? I can multiply by 3 to get 2. I can multiply by 2 to get 3, but that's a total pain. I got to use fractions, right? Is there anything easier? Well, look at the y's. If this is 2, what would I like this to be? Negative 2, right? So right now it's a 1. If I multiply this equation by negative 2, then that y becomes a negative 2y, and that's what I was looking for, right? So the first one, I didn't do anything to. The second one, I'm going to multiply by negative 2. And now, if I ask you guys, what happens when you add the equations together? 3x minus 4x, negative x. 2y added to negative 2y, gone. Negative 9 and 14 is 5. So if negative x equals 5, positive x equals negative 5. So there's the one answer that I know is correct because we just checked it a minute ago. And then how do I get the other value? I plug it back into what? What do you mean any equation? So into one of these, would that be okay? Yeah, I could plug it into any equation on here. I could plug it into this one, this one, this one, or this one. It doesn't matter. So I always look for the one that is what? Like less complicated, right? Like the one with like the smallest numbers. And I mean, really, right? That's what I'm going to do. So I'll take this one. That's the one that looks like it's got the smallest numbers in it. So there's a way to solve it, right? Now, guys, the other way to solve it, so what did I show you? I showed you guys the elimination method, right? That's the elimination method. I showed you how to use lin solve, right? Guys, couldn't I have also graphed this as a relation, graphed this as a relation, and saw where they intersected, right? So there's another way to do the exact same problem. Are we okay with that? All right. Now, in part B, I have the exact same problem here, right? Well, take a little note, guys. This right here was the elimination method. All right. In part B, I'm going to do the exact same problem using the substitution method. Now, the substitution method would not be a bad option for this particular problem. Here's why. Can you get a variable alone easily in either one of these equations? Yeah, I would agree. In the second equation, it wouldn't be too bad to get that by itself, would it? All I would need to do is subtract the 2x. So that means that y is equal to negative 7 minus 2x. Well, if that's the value of y in this problem, that's the value of y everywhere in this problem, right? So isn't it true that this y has the same value as this y up there? Well, if these two y's are equal and y equals this expression right here, then I should be able to do what? Substitute this for that y. So I'm going to take this equation up here, and I'm going to take this piece, and I'm literally going to plug it in where that y is. So what's it going to look like? 3x plus 2 times negative 7 minus 2x equals negative 9, right? And now this becomes, a little bit of an algebraic problem that we got to solve. Got to distribute the 2, right? So if negative x equals 5, positive x equals negative 5, and nobody's shocked or surprised, so we get the same answer. The one kind of nice thing about what just happened is that the equation over here that we solved for a minute ago already has y by itself, right? So it's easy now to get the value for y because it's already set up for it. And there's our y equals 3. These are things that those of you that took algebra last year spent, I don't know, 2 weeks doing? A long time, right? Those of you that took geometry last year haven't seen this in a long time, right? So there it is. Okay. This was just using the calculator, right? All right. Well, what's going on now? And this is going to be new for everybody. What did I do to you? I gave you an additional equation and an additional variable. Well, the good news is that when we go to LinSolve, that first little screen that pops up asks me if I want to do what? Add an equation. And so when I choose 3 equations, it'll now give me 3 variables. And that means that I can type them in. And guys, here's the thing, right? Like, all right, not to offend, all right? But like, one of the things that worries me about your generation, and I'm not like old, right? I'm not. I'm not like, I don't think I'm like an old guy, but like I still think of you guys as like, you know, a new generation. Is that like you've sort of adopted the mindset that close enough is okay. Like in other words, when you're sending a text, right? Like if you misspell stuff, you're not like, oops, I gotta go back and fix that. You're sending it, right? You know, like gone, sent, gone, sent, right? As long as I can get the idea across, that's good enough, right? And that mindset has infiltrated itself into the math classroom. And so what happens is, like with this, right? If it's not absolutely 100% perfect, what happens? You get the wrong answer, right? I mean, and it's something as simple as I just missed that sign, and now all of a sudden I get this. And I guarantee you, with without a single doubt in my mind, that there is somebody in the room who will not admit it, who got an answer that looks something like that. Okay? Right? Somebody, I don't know who it is, but I guarantee you. All right, so you really just got to be careful when you type it in, okay? And you're going to get the right answer, guaranteed. But you got to type it in right, okay? 7, 3, and -2. Okay? And here's the thing. I know, right? I know that Mo is sitting there thinking to himself, well, great. Like, I got the answer. Why do I need to do anything now? Like, it's crazy. It's just, it's, you know, it's just one of those things. There's going to be times, guys, where I am more than capable to admit that this is a waste of time, but you still got to know it, okay? There are certain things in this class that I'm going to say, guys, you'll never, ever, ever see this again. Like, this is the only time, okay? It's just kind of the way it is. So we got to come up with a strategy to be able to solve these, right? Now, here's the problem. The problem that you have, and I guarantee, again, that there's somebody in the room who's thinking to themselves, okay, I'm going to add all the X's together. I'm going to add all the Y's together. I'm going to add all the Z's together, and hopefully a whole bunch of stuff goes away. And that's kind of the right mindset, okay? That's kind of the right mindset. I'm going to give you a challenge, right? Here's the challenge. The challenge is I want to get rid of 2 of the same variables. In other words, I want to get rid of like both of those, or I want to get rid of like both of those, or maybe I want to get rid of like this one and this one. So the first thing you need to think is I need to get rid, actually better, hang on, backtrack. So the first thing I want to think is which variable do I need to eliminate, okay? And right now, the answer to that should not be clear, okay? You shouldn't know quite yet because I haven't explained it to you, all right? So which variable am I going to want to eliminate? So that's the very first question you're going to ask yourself. And then the second thing you're going to say is I need to get rid of 2 of them. Right? So that's sort of your aim, okay? I want to decide the variable to get rid of, and I want to get rid of 2 of them. And the way you're going to do so is very similar, guys, to what we just did on the previous page. Here I have a 2, 6, and -4. Are any of these things that I could add together to get something to eliminate right now, right this very second? No. Here I have a 1, -3, and 4. Is there anything I can add these together? Is there any way I can add these together to get something to eliminate right now, right this very second? No. Here I have Z, -Z, and -Z. Can I add any of these together to get something to eliminate? Boom. So right away, you've found the variable that you want to go after because that means less work. Okay? So that's the thought process. The thought process is which variable can I most easily get to eliminate? And I would agree you're looking for what? You're looking for numbers and numbers opposites, right? Hey, quick question. I could get rid of the x's, correct? If this were a 6 and this were a -6, or if this is a -4 and this is a +4, right? So it doesn't mean that the z's are the only option. There are others. It's just right now the thing that would create the least amount of work would be the z's. Does that make sense? Okay, I'm going to stop right there. We're going to pick this up next week.